Okay, hello everyone. We meet again in the next video. So then here I'll be discussing about how to solve modulus equations now by using the idea of squaring both sides. In the previous video I mentioned about we use a concept, right, to solve the modulus equations, whereas we are talking about the very definition of modulus equation or modulus function by using this. So we kind of have to go back to this concept all the time whenever we want to solve the modulus equations. So if you prefer that method, go ahead with it, but then stick to it. So whenever you're dealing with modulus inequalities later, you will need that same very concept. So over here, what I will be talking about is how to solve the same modulus equation, exactly the same, but by using squaring both sides. So as its name, right? So let's say talking about the first one, the 2x minus 1 modulus equals 3 as the name, so we have to square both sides. And remember, because this is squaring both sides, make sure that everything is squared, right? So we have 4x squared minus 4x plus 1 equals 9. And then we'll get into this. So to make it simple, let's divide by 4. Then we factorize, right? So we have now the solution of x equals 2 or x equals -1. So do we need to check in this case? Not needed. In general, not needed. Do we need to check? But if you want, then just do the checking. When x equals 2, 2x minus 1 means modulus of 2 times 2 minus 1, which is a 3, or modulus of 3, and it's a 3, so it's true, right? That's correct. When x equals -1, you basically do the same thing. Then you'll get this is -3 modulus, so it's also 3, so it's true. So no problem with this, right? Now the second type, 2x minus 1 modulus with a non-modulus function, right? So instead here we do the same thing again, which will produce us same thing on the right side, but on the left side, the right side we will have 9x squared plus 6x plus 1. We rearrange, so we'll have this equals 0. Typically for me, I always want my quadratic function or quadratic equation to be non-negative, the coefficient of a, so I'll usually divide by this. So I have this, then only I factorize. So x equals 0 over here, and x equals -2. Right? So we got two solutions. Now the question is that, do we need to check? So again, as I mentioned in the previous video, be really careful whenever you actually square, because it's like you're converting to quadratics, right? Now for the case of modulus, it's fine, because in terms of the graph it looked like this, right? So it looks like a modulus. But for this guy, whenever you sketch the graph, the actual graph looks like this. So if you square both sides, it means you want to make it like this, which means it's different graphs, right? Different in terms of any ways. So you have to be really careful whenever you're dealing with this type, and then you square both sides. Even if I refer back to our discussion in the same type of question, yes, this one, type 2, you still need to check, right? And then it turns out there is only one solution, the x equals 0. So let's do the same thing. Let's do a check over here. But the way we check here is not by using the definition. You can by using the definition, or you can just plug in the value. When x equals 0, 2 times 0 minus 1, which is 1. And then the other one is 3 times 0 plus 1 is also 1. So it's good. When x equals -2, however, is the problem. 2 times -2 minus 1 gives us modulus -5, which is a 5. And the problem comes with the right one. 3 -2 plus 1 gives us -5. In terms of the number 5, they are same, but then this is negative and cannot be a modulus, right? Cannot be positive. So this one is not okay. So the solution is x equals 0. So consistent with the previous video, right? The concept. So the next one, And question C, the same thing like before, but both of them modulus. Guess what? You probably know already the answers, right? Because practically the way we do it will be exactly the same, but this time, this guy with modulus. So if you know this before, this one will definitely be positive 5. So it means both of them will be the answer. But then let's just do the tedious working, right? So I'll just skip through this, then we'll get x equals 0, x equals -2. But in the case of this, normally you don't really have to check because both of them will be modulus already, right? So then, because both of them are modulus, checking is not really necessary here. It is not necessary because if you work on the solution correctly, the two modulus make sure that both will be non-negative, right? So then it's fine. Now the reason why we need to check for this case is that it's possible, let me put it here, this guy possible to be negative. That's something that you have to be careful in that sense. So I hope that makes sense to you. So let me take also again one example. Where is it from the exercise? Wait, let me see where the textbook exercise is. Here. So let me go to this and then let's take a different question compared to the last one, right? So let's say I'll make it a little bit more complicated. Let's say we are talking about the question number 3. Okay, this is a different typical question. So given 6, number 3, given 6 modulus x plus 2 squared plus 7x plus 2 modulus -3 equals 0. Now if you look at this particular problem, I don't know whether you know this or not, but then if let's say you change the x plus 2 with a, this will be a squared and this will be just a, right? So it looks like it will be just 6a squared plus 7a minus 3 equals 0, which is, it's just an ordinary quadratic equation, right? So, but then the look of the first question looks so complicated, but it turns out we can make it easier. So we can actually let or assume a to be modulus of x plus 2. So how do we deal with this? Just normal quadratic equation. You factorize. So we will have this, right? Plus 9 -2. So 3a minus 1, 2a plus 3. So a is 1/3 and a is -3/2. But guess what? The a is not the a. The a is not the final one that we want to have, but it's still the x. So let's put it back again. Let's put it back again. Okay, so let's now we have this. This one is okay, we can try to solve it. But this one definitely doesn't make sense, even though it seems like you can square both sides. But it will not make sense because this guy is negative already. So then we can already tell that this is impossible. So you don't need to work on this one. So let's just work on the left one. Here, if you square both sides, then you'll get this. X squared plus 4x plus 4 equals 19. If you're the similar type like me, then you'll prefer to multiply everything first. Though it's not necessary. It's just that a preference. Some of us prefer this, some of us is okay with the fraction. Then you solve it. If you think that this one is too complicated, then you just prefer to, multiply using the quadratic formula, and that's also fine. So, so if we look into this, 315, well, that's a big of a number. So I must think for a while. See, right? 315, you multiply, you will get 315. If you plus, you'll get 36. What should be the number? 315, 35 and 9, so 27, probably 45. Okay, I think that may be too complicated, so then to make it simple, let's just use the quadratic formula, right? So then we can use the calculator directly by using this method. Anyway, so 2 times 9. Then you can use calculator for this directly. Unfortunately, I don't have one with me. So this will be, apparently it will be 36 only. It seems like, so 36 squared minus 36 times 35. So I can make it as 36 minus 35. So apparently it's just 36. So we can get into negative 36 plus minus 6 over 18. So apparently there are two solutions, negative 36 minus 6 over 18, or negative 36 plus 6 over 18. So we can get, this is negative 42 over 18, and this is negative 30 over 18, and you can simplify it by yourself. And that's the two solution. For the other parts, also the same. Let's say this one, you can square both sides like this. Then you factorize if needed, like this. So then see, you get two solutions again, 1/3 and 1. And you don't need to check, but if you want to check, go ahead, it's okay. So here it is, how you solve modulus equations, again, by using squaring both sides. And then again, before I finish the video, where we end the video, I'll just remind you of the conclusion that we have for the modulus equations. Please do remember this. Whenever we deal with modulus inequalities after this, there will be another video for that. We'll need the concept. Again, we'll need the concept, we'll need this too, and then we'll also need the graphs later on. So then we can help, it can help us check whether our solutions are correct or not. Okay, so please think about it in the sense that try to think about like how do you deal with the modulus inequalities by yourself first before you probably watch the videos. Okay, see you in the next video.